Okay, we just finished our channel interpolation set. So the next step will be to set up the channel boundary conditions, apply the two hydraulic structures that represent the tide gates, export the project, run the simulation, and then create a backup file. And then the final video on this set will be a channel review video. So we'll be opening up some of those data and to review the channel. So just bear with us because this first process might seem like you're doing things that you don't quite understand. Also, please ignore the placeholder video. They'll be replaced with the video that you're going to see right now in as soon as I'm finished with it. So let's start with the channel inlet. So now we don't really need our elevation map anymore, so we can uncheck that, and then we'll want to zoom in to the beginning of the channel. Now remember, I'm just using my roller wheel to zoom in and out. And this is gonna look kind of weird because I'm starting my channel right in the middle of this bridge. But if you look at your elevation data kind of cuts that bridge out for you. So it's okay to do that. Now I actually sampled the elevation from this spot, so it doesn't have that roadway in there. I'm just the whole thing is just kind of dropped down to, the bank of the channel. It's not really taking into account that roadway. So if you're wondering why I did that, it was really just because I overlapped the grid and I didn't want to start the channel like downstream of this because my channel data goes all the way to here. So if that's a little weird to you, you might want to start your project over here, or you might want to start your project over here. I just started it right on the roadway because they're usually a pretty good natural boundary, or well, I guess they're not really natural, but you get the point. Now let's go ahead and zoom in here. Now all boundary conditions in the channel are always assigned to the left bank. So I'm going to show you, first of all, I don't need these user layers anymore. So I'm going to turn them off so that we can see the schematized bank. And the grid's I'm going to turn this image off real quick so you can see this better. That's better. So here's your computational domain. We don't really need that right now, but here's your grid. And this is your first grid element and first channel element. On the left side looking downstream, you can see the little arrows pointing the downstream. That's exactly what you want that to look like. Now let's go over here and collapse our widgets and open up our boundary condition editor. This time we're not going to use a polygon, we're going to use a point. So grab the grab the point button and then click that line, and then you just have to click OK. It's done. Now come back over here, save it, and then click OK again. Now we have our first inflow condition. Now if you want, you can say Cocoa in or whatever. You can name it, you can, and we can set it from floodplain to channel because it's going to apply the inflow to the whole cross section, not to this cell right here. It's going to apply it to the whole cross section. And I can also name that time series. This is the 100-year, 24-hour storm for this canal. So it's an inflow hydrograph that brings the water in from the canal, probably based on a HEC1 analysis or HEC-HMS analysis. I'm not really sure where the data came from. And then in addition to that, we also have the rain on the grid. That represents the flow coming in from other boundaries. So in this case, we're going to keep the project training simple, but there may be additional locations where you have inflow coming in. So let's get back out here to this map. So yeah, see, there may be some inflow coming across and into this area if there's some kind of culvert or something under here. I don't really know if that's the case or not. But that does make a great, wonderful natural boundary. And there may be some boundaries along this golf course that also flow across our system. It doesn't really look like it. It looks like I got most of that area kind of isolated and it kind of probably self-contained, but it may drain into our area, and then you would need another inflow node to account for that. So just be aware of that. Now, with the boundary condition, we're going to do the same thing we always do, and that is to get that table, or that rating table data, or it's not rating table, sorry, it's a hydrograph data, and then add it to the map. So we go get the widget, click the button, put the point where we want it to go, save it, change it to inflow, and then change all the data, and then we get the data from the text file. So let me grab the text file. It's in our boundary condition folder. So back here, coastal training, project data, boundary conditions, and then I have the inflow hydrograph right here. So it's the same as always, Control A, C, W. And we go back to our table here and paste. And then we'll get that discharge for the Cocohatchee 100-year event. And that is done. So all we have to do is click the schema button to convert the data from user data into Flow2D grid data. And we are basically finished. Now on the downstream boundary of the channel, this is kind of a funny case because we don't really have to do anything. I could have run this channel all the way up to the boundary and then just assigned my tide stage right here, but I chose not to do that so that you can see that there are two different ways to go about building these channels. So you can run your channel all the way to the boundary and apply the tide condition to your channel. In that case, you would just use a point and you would do one here and one here, and just like you see here. So this would be the regular outflow node, and this would be the time stage node. And you would do that regular outflow node time stage node just like that. The time stage node goes in this cell and that one. But because I just put this channel right here and ended it, and let me show you what that cross section looks like. I'm going to grab that last cross section. This cross section is just about -4 feet in elevation, and these cells right here are about -4.1 feet in elevation. So this cross section is just slightly raised up above those points so that the water will flow out of the channel onto the surface and then toward the outflow nodes. The same thing is going to happen with the tide control. At the beginning of the simulation, before the rainfall starts, the tide is going to come up, go into the channel and start to fill the channel from the downstream side. It's an actual time control, time-related control right there. So you don't have to do anything in this particular channel. You just need to make sure that you set it up so that it's terminating correctly, or you can bring it all the way down and set the tide control to the channel instead of to the floodplain. You can do it both ways. All right, so that's boundary conditions. Let's go ahead and see what's next. I think that gets us to outlet. And then we go ahead and set up the tide gates. So we have two control structures. I'm going to set those up again. Because this channel is so flat and the water in this channel, there's not much slope in here and the water's moving really well, but because it's so flat, the downstream water surface and the upstream water surfaces across these bridge structures doesn't really change a whole lot. And there's not a whole lot of piers and stuff in here, and the water never gets up on the deck. Even if we give it like that full discharge, it never gets up on the deck of these bridges. So I'm just going to leave these bridges alone. I might increase the N value of the cells going through these bridges, but I'm not going to worry about modeling the hydraulic structures on these bridges. All right, let's see. Let's get down here to this first weir. And what we're going to do is we're going to use the structure editor to add weir number 1 and weir number 2. So let's go ahead and get in here and let's zoom in on the first weir, which is right here. So I think this one's called Coco 1. Yeah, you can even see it here if you zoom in one. Yeah, CC1. And what we can do is we can use our structure editor. So again, remember, collapse your widgets Always collapse your widgets. Don't leave a bunch of them open. There's a rhyme for that reason. Okay, and then we're going to use this guy here, and we're just going to put these two side by side. One will represent the upstream side, and the next one will represent the downstream side. Then you right-click and click OK. That one is done for the digitizing part. Then we'll go upstream to the other one, and I'm just using my arrow key, my right arrow key, just to quickly get me up there because I don't quite know where it is. And we'll do the same exact thing. We're going to try to just, this one looks like it goes from this one to this one, and then right click and OK. And that is done. Come back over to the cross section, or sorry, the structure editor, click save, and then you can start naming the structures and setting them up. So let's switch back to structure one, and if you center it and you switch between them, it'll quickly position your map right on the structure you're working on. So let's call this one CC1 or Coco1, and I'll click OK. It goes from channel to channel. Okay, so it's a channel to channel structure. It's going to have a rating table, and we're going to allow upstream flow because it's a tide gate. Now, so that one's finished. We're going to go up to the next one, Coco 2, CC2 right there, and we're going to do the exact same thing. So Coco 2, you can name it CC2, whatever, it doesn't matter. You can name it, change it to channel, put it to a rating table, and set the tailwater to allow upstream flow. That way, if you want to run it in a simulation where you have kind of like it's dry here, I don't know if those tides are going to infiltrate and come all the way up in here or not. This is quite a bit higher than this Coco 2 is quite a bit higher than the ground surface, but I believe that the gates just keep the water from flowing out so that enough water stays in here that they don't get stinky and gross in the dry season. And it probably helps the water tables and stuff. Okay, so now that's done. The next step is to grab the data, the rating table data. Now, if you go to your project data, we have the weir. The weirs are right here, and there's just two files in there. You can see how the files are set up. They're just, sorry, this is depth on the left, discharge on the right. But we don't have to copy paste in this case because we have a little importer. And I'm going to get that channel importer done too, but that's kind of time consuming. So I'm going to import the rating tables, and I'm just going to grab them both and click open. And it will, now the process is already finished, but if you change the position of the map, you can see that the two rating tables are basically the same for both structures. And I think it is fine in this case because the structures are almost the same, based on like their gate openings and the weir over here. So they're basically the same structure, even though this one's quite a bit higher in elevation, it's still doing the same hydraulics. So the rating tables are basically the same. Now let's see, now that's finished. So I'm going to go ahead and over here and click schematize. Now, if you want to develop your rating table for this structure, because it's complicated, you can get it from the as-build or the design discharge attributes from the design data, or you can calculate your own, like you have an opening here, you have an opening here, and you have an opening here, and you just basically combine those into a single rating table, and you can create the rating table from this. Or you can get the discharge data, because this has like some gauge data associated with it. You can get the discharge data through it as well. I think that's how we did it. And once you schematize it, they're basically done. But you do still need to turn on that processor switch. So come over here to the control panel, turn on your hydraulic structures, and then click save, because we don't really need to do anything else. Just click save. And now that's done. And now we need to set up to do the actual run. Because we want to look at the run, and once it's finished, we want to look at the channel and look at the results. So let's go ahead and get the channel running while we work on other things. Okay, so we will be exporting the project into the Weir test folder. Okay, so I got my project export folder, and I'm just going to make a new folder called the Weir export test. I've already done it, so I want to come over here, well, and select the folder that will export the data. I guess I can do that. Yeah, I think I can do that without hurting my data. It's going to tell me when it's done. The project is getting big, so it's taking a little bit more time to export. That's to be expected. And then come here to the project data, and you have two choices when you run Flow2D. Sorry, I need to be in the coastal training folder. Project export, now I got my Flow2D and all these DLLs in here, so I can just run it like that, or I can run it from here like we did last time. Either way is perfectly fine. Now I already ran this, so rather than starting it and running it again, I'm just gonna show you that. Hopefully we'll see if this works. I'm just gonna open the profiles program, and then I'm gonna click view profiles, and I'm going to click the maximum water surface elevation, and just to show you that the run is already complete. Now I'm going to stop the video here. Well, actually, I'm not. That's not true. Sorry, I'm getting ahead of myself. Okay, we exported the project. We turned on our switches, exported the data, and we started the run. That's step 13. You can either run from here or you can do it the way I did it. And then save the project, close QGIS, and create a backup file. It's very important to create this backup file because if you ever messed anything up, you saw how much work it took to get those channels in there. We don't want to have to do that again, right? So I'm going to minimize this, go back to QGIS, save the data. I'm going to close it, go back to coastal training. Give me 1 second. Compress these two files together. Remember, always close QGIS before you do this step. And let's just call this Chan and Weir OK. And then I will put this in my backup files so that this map stays clean. And I already have one in there, so I'm just going to skip it. And then I'll just delete it because I don't really need it, because as you can see, I had already had one in there. I'm going to delete that. And that channel is basically finished, except we have to still review it, and we might need to go back into it and fix it if something's wrong with it. So I'm going to stop the recording. The next video will be channel review.